Okay, now I'm going to follow on with some further results from our treatment testing studies. This one focusing on HDAC inhibitor compounds that we have been testing. So as we've already mentioned, we have the zebrafish model and we can test different treatments on it. And because of this capacity, we first of all needed to choose which treatments we would test. And so in the early stages of this project, we focused on a candidate-based approach where we chose treatments that might target different mechanisms or pathogenic mechanisms that maybe we could rectify to treat the disease. And one of these that we decided to have a look into was the potential of looking at transcription deregulation. And the reason for this is that one of the functions of normal Ataxin 3 is actually to be a transcription regulator, as it has histone binding activity. And so what does this actually mean? Okay, so histones are proteins and they have DNA coiled around them, and the histones can be modified with acetylation, which you can see as these red dots. And if there is a lot of acetylation, then this coiling becomes relaxed and you end up with increased transcription levels, and that leads to increased protein expression. But in contrast, if the amount of acetylation is decreased, then the coiled DNA is more relaxed, condensed, and transcription levels are decreased. So it's actually been previously reported that the polyQ region of Ataxin 3 is a histone binding, has histone binding activity, and that when that polyQ region is expanded in the disease, it may lead to too much interaction, which may impair acetylation and lead to more of this bottom situation where we have deacetylated histones. And this has been reported for other models of MJD, such as here is HEX cells, where you can see in the last column that there is decreased levels of this acetylated histones in the long polyQ expressing cells. And in our zebrafish model, we noted that there was also this tendency as well, and that levels of histone 3 acetylation were also significantly decreased in the zebrafish acetylated histone 3s. So we thought, why not try treating the zebrafish with something that's known as a HDAC inhibitor, which means a histone deacetylase inhibitor, which may rectify this. So one of the HDAC inhibitors that we decided to test is sodium valproate. This drug has already got approval for use in humans for the treatment of epilepsy and bipolar disorder. And it has been shown to have some positive effects in some preclinical trial studies, but not all. And we wanted to see what happens in our animal model if we treat with this drug. So we treated with sodium valproate, and we saw that there, at this, which is a pretty low concentration, that there was a rescue in the swimming phenotype. So they swam longer distances, and indeed there was elevated levels of this histone acetylation, which you can see here. But the thing that was really interesting to us was that in addition to that, there was also an increase in the amount of expressed human Ataxin 3 within the zebrafish following sodium valproate treatment. This was surprising to us because usually in our model, if we have an improved swimming phenotype, it's usually occurred when we also have decreased levels of human Ataxin 3, the polyQ expanded form. So we thought, what other proteins might also be expressed at higher levels because of this treatment? And is there perhaps a pathway that's been activated and maybe it's neuroprotective? So in order to explore that, we formed a collaboration with some researchers with expertise in proteomics, and they performed proteomics on our samples from zebrafish that were either treated with sodium valproate or treated with a vehicle control. And they looked at the levels of different protein expression and they identified 61 proteins that were downregulated and 84 proteins that were upregulated. And you can see some of them indicated here, green for downregulated and red for upregulated. Following on from this, they performed Ingenuity pathway analysis, and they identified that this treatment had increased, was predicted to increase activity of the sirtuin pathway. And this is actually a novel finding and hasn't been previously reported for sodium valproate to our knowledge. So, first of all, following on from that, Maxine confirmed these findings because it was a prediction from the proteomics, and she did find in independent samples that an important member of this pathway is increased following sodium valproate, and another member is decreased as it should be within the pathway. So why would we care? Well, the sirtuin pathway is something that actually has previously been shown to be neuroprotective and to be related to survival and longevity. And it is thought to act through potentially decreasing apoptosis and inflammation. It also has been reported to play a role in induction and regulation of autophagy, which we've heard about a few times today. So first of all, in the zebrafish samples, Maxine quickly confirmed that following sodium valproate treatment, there is an increase in LC3-1 levels. And then we expanded the study also into HEX cells to confirm whether this treatment on these cells also resulted in induction of this pathway. So treatment with a higher concentration of sodium valproate did induce a large increase in histone acetylation, and indeed did increase levels of SIRT1, suggesting increased activity of this pathway, and decreased acetylated P53, which is a substrate of this pathway. Following on in the cells, Luan also confirmed that there were increased levels of LC3-2 following treatment with sodium valproate, and that this was increased further if we blocked the pathway, which is a good way of proving induction of autophagy. But this is not a new finding for sodium valproate. It's known to induce this pathway. If we stain for LC3, we also find that there appeared to be increased cytosolic LC3, and this was interesting because it follows on from a previous suggestion that the SIRT1 may deacetylate LC3, leading to it transferring to the cytoplasm to aid protein aggregate removal. And we thought this might be a further evidence of the sirtuin pathway being induced. So we've now embarked on treating with sodium valproate along with a inhibitor of the sirtuin pathway, EX527, to try and see if we can prove that whether or not the induction of autophagy was dependent on activity of the sirtuin pathway. But that work is still underway. But importantly, we're also going to co-treat the zebrafish that receives the sodium valproate to see if inhibiting the sirtuin pathway prevents that protective effect, the increased swimming phenotype. Following on from that, we also tested another HDAC inhibitor, which is Resveratrol. This is found apparently in red wine, but at extremely low levels, so don't try drinking excessive red wine to achieve this. It has also been reported to be linked with survival and longevity, and it does also induce activity of the sirtuin pathway, and resveratrol has also been shown to have protective effects for MJD mouse model. So yes, we saw that there was increased histone acetylation, and there was an improved swimming phenotype following resveratrol treatment, and indeed increased SIRT1 levels. So again, another suggestion that perhaps this pathway is a good candidate for exploring potential treatments. So to conclude, we have found that there are 3 different HDAC inhibitors that improve the swimming phenotype, which are the 2 I spoke about, and also sodium butyrate, which Katie spoke of earlier. We've seen that the sodium valproate increases activity of the sirtuin pathway, It also induces autophagy, and we're currently exploring if these two things are dependent on each other. And we're now embarking on testing for if there are other drugs or compounds that might also induce activity of this pathway and have protective effects for the treatment of MJD. So I'd like to finish by thanking again the researchers, MJD Foundation and ALC, and the zebrafish facility team. And I've got a poster presentation this evening on this if you would like to ask me any further questions or if you have any suggestions. Okay, great.
We've got time for one question.
Yep. Lewis.
Thank you very much. Very nice presentation. So I'm curious, as you know, we've showed in the past that the deactivation of SIRT1 is extremely effective in alleviating MJD. And my question is whether you try to silence SIRT1 and at the same time use the HDAC inhibitors, because this would demonstrate that dialing the HDAC inhibitors are mediating its beneficial effect through the SIRT1 pathway, which I would expect is the case.
Yep, so we've been embarking on doing it through the inhibitor co-treatments, but this is probably something we should test because in the zebrafish we can easily knock out. So as long as that doesn't... You would ask for this? Okay, yeah. Thanks a lot for the suggestion. Thanks.